Before a system can allow or deny access, it first needs to answer a simple question. Who is making the request? Think about it. If your backend receives a request to access user data, it can't decide anything until it knows the identity behind that request. It could be a real user, a mobile app, or even another service. Without verifying identity first, your system would be blindly trusting every request, which is a huge security risk. That's where authentication comes in. It acts as the system's first line of defense, making sure every request has a verified identity before anything else happens. This is where many developers get confused. Terms like JWT, OAuth2, bearer tokens, and single sign-on are often used interchangeably, but they actually mean very different things. JWT is just a format for structuring data inside a token. OAuth2 is a framework for granting permissions. Bearer tokens describe how a token is used, and single sign-on is simply a user experience. Mixing these up can lead to poor design decisions, like using the wrong tool for the wrong problem, or misunderstanding how secure your system actually is. So, throughout this video, we'll separate these concepts clearly and understand how they fit together. At its core, authentication answers one question: who are you? Imagine your system as multiple layers: an API gateway, backend services, and every request must pass through these layers. But before it reaches any of them, the system needs proof of identity. So the user sends a login request with credentials. The server verifies those credentials, and if they're valid, the user is allowed in. If not, the system responds with a 401 unauthorized error, essentially saying, "I don't know who you are." Only after this step can the system move on to authorization, deciding what the user is allowed to do. Let's start with basic authentication, the simplest and most straightforward method. The client sends a request, gets rejected, and then retries with the username and password encoded in base64. Now here's the important part. Base64 is not encryption. It's just encoding. That means anyone who intercepts the request can easily decode it and retrieve the original credentials. Even though HTTPs can protect the data in transit, this method is still considered weak because credentials are sent with every request. That's why basic authentication is mostly limited to internal tools or simple systems and rarely used in modern production environments. Digest authentication improves on this idea slightly. Instead of sending the raw password, it sends a hashed version using MD5. This prevents the password from being directly exposed, but MD5 itself is no longer considered secure, and the overall approach still has limitations. So while it was an improvement at the time, it's now outdated and has been replaced by more robust solutions. API key authentication is commonly used, especially for service-to-service communication. Each client is assigned a unique key, which acts like an identifier. This key is included in every request. When the server receives the request, it looks up the key in a database to verify it and determine what access is allowed. But here's the issue. API keys are essentially static secrets. If someone gets access to that key through a leak or insecure storage, they can use it freely. There's also no built-in expiration or identity information inside the key itself, so the server always needs to look it up. That makes API keys simple, but not the most secure or scalable option. Session-based authentication is the traditional approach used by many web applications. When a user logs in, the server creates a session and stores it either in memory, a database, or a cache like Redis. The client receives a session ID, usually stored in a cookie. From that point on, every request includes that cookie, and the server checks if the session exists. This works well, but it comes with a trade-off. The system is stateful. That means the server must keep track of every active session. As your application grows, managing and scaling these sessions becomes more complex, especially in distributed systems. Modern systems often move away from sessions and use token-based authentication instead. Here, the user logs in once and receives a token. This token is then sent with every request. The term bearer token simply means that whoever holds the token is granted access, so protecting it is critical. The most common type is a JSON Web Token, or JWTA. JWT contains structured data like the user's identity, expiration time, and permissions, and it's digitally signed to prevent tampering. Because the server can verify the signature without checking a database, this approach is stateless. That makes it faster, more scalable, and ideal for distributed systems. To balance security and usability, modern systems use two types of tokens. Access tokens are short-lived and used for actual API requests. If one is compromised, it only works for a limited time. Refresh tokens, on the other hand, last much longer and are used to generate new access tokens. This means users don't have to log in repeatedly, while the system still limits risk. However, Refresh tokens must be handled very carefully. They should be stored securely, typically in HTTP-only cookies to prevent attacks like cross-site scripting. OAuth 2 is one of the most misunderstood concepts. It's not about logging users, and it's about granting permissions. For example, when you connect an app to your Google Drive, you're allowing that app to access your files. OAuth 2 handles this by issuing an access token after user consent. But that token doesn't prove who you are. It only proves that the application has permission to access certain resources. That distinction is critical. OpenID Connect builds on top of OAuth 2 and adds identity. When you sign in with a provider like Google, you receive an ID token along with the access token. This ID token is a JWT that contains verified information about the user. Now, the application not only has permission to access resources, but also knows exactly who the user is. That's what makes OpenID Connect a complete authentication solution. Single sign-on, or SSO, focuses on user experience. Instead of logging in multiple times, the user logs in once and gains access to multiple systems. Behind the scenes, a central identity provider manages the session and shares it across services. This makes the experience seamless while still maintaining security through trusted protocols. SSO relies on identity protocols like SAML and OpenID Connect. SAML is older and uses XML-based messages. It's still widely used in enterprise environments. OpenID Connect is more modern, using JSON and JWTs, making it easier to integrate with modern applications. Both approaches are secure. The main difference lies in complexity, flexibility, and how modern the system is. Authentication is about identity. It answers the question, who are you? Authorization comes after, and it answers a different question. What are you allowed to do? Getting this distinction right is essential for building systems that are both secure and scalable. And that's a complete breakdown of authentication, from the basics all the way to modern systems like JWT, OAuth 2, and OpenID Connect. If this helped clarify things for you, make sure to hit the like button and subscribe for more deep dives into system design and back-end concepts. In the next video, we'll take this a step further and explore authorization, how systems decide what users are actually allowed to do once they're authenticated. If you have questions or topics you want covered, drop them in the comments below. Thanks for watching, and I'll see you in the next one.